My name is Russell Hancock. I'm the president and CEO of Joint Venture Silicon Valley Network, the organization that has organized today's proceeding. I want to thank you for being here. I want to thank you and salute you for the important work that you're doing. Our hope at Joint Venture is that energy storage can become a Silicon Valley strength. And that's the reason we're here today, to talk about what that is going to take and what the next steps might be. And we'll be hearing expert opinion from a number of distinguished thinkers and practitioners. And so we're grateful that they would come and that you would be here to participate. I want to say just a brief word about Joint Venture so that all of this has some context for you. What is Joint Venture, Silicon Valley Network? Well, we're an organization that brings together the public sector and the private sector. That's why we call it joint venture. It's a collaborative undertaking between government and business. And our mission is simply Silicon Valley. So this is an organization that is actually tackling a number of regional issues that pertain to our region's quality of life, our economic competitiveness, and our long-term strategic outlook. You'll find joint venture working on any range of things: tax and fiscal issues, urban planning and design, education, disaster planning and preparation, and most recently, a whole portfolio of activities focused on climate change, our nation's energy future, the emergence of clean technology, and Silicon Valley's role in the emergence of that cluster of industries, and our great hope that it not only solves important energy problems, but that it also leads us onto a path out of recession. So we're doing a great deal of work in that area. And we launched this work with a publication that we entitled Climate Prosperity. You have, I hope, one of these cards. It's linking you to that report. And if you haven't looked at that report, I hope you'll look at the report, because it provides the umbrella. It provides the conceptual underpinnings for everything that we're talking about today and everything that we're trying to accomplish on a regional scale. And because we're trying to be green, we didn't print the report. It's only available to you online, but there's this card. We'll give you the link to it, and it'll tell you a little bit more about what we're doing. So we hope you'll understand that everything happening today is in that context, that this is a large, long-term, region-wide effort to position Silicon Valley as the leader in clean technologies and as the place that is providing path-breaking leadership to the solutions that will help us address climate change. Now, I'm anxious to sit down and to have our keynote speaker come forward, and so that we can delve immediately into the substantive portion of our event today. But before I do, I just want to introduce two very important people. Kelly Kirpata, stand please, and Rachel Massaro, if you would stand please. A member of the joint venture team. Kelly is our Applied Materials Director of Climate Prosperity at Joint Venture. Rachel Massaro is the Associate Director. The two of them have organized this event today. Rachel has done the bulk of the work, and so I salute her and congratulate her for that. It really has been a great effort. And I want you to know that Rachel and Kelly will then play the role throughout the day of host, narrator, master of ceremonies. They'll be the ones that are moving people on and off stage and keeping us on time and on task. So thank you. And now I would like to introduce a member of the Climate Prosperity Council. He is Tom McCalmont, who has vast experience in these industries, in the solar industry in particular. He now heads up his own firm, McCalmont Engineering. We have asked Tom if he would introduce our keynote speaker. Thank you, Tom.
Thank you, Russ. Good morning, everyone. As many of you know, I'm a passionate advocate for solar power. And one of the beauties of solar power is it's very complementary to the grid. It produces power when we need it the most, in the hot and sunny times of day when the air conditioning loads tend to be their greatest. But that's not the same, that same characteristic cannot be said for all forms of power or even all forms of renewables. And many of them are challenged, such as wind power, in that they produce their power at night. And so what's really critical to the future of these forms of power is some way to time shift that power from one time of day to another. Hence the need for this conference and the important topic of energy storage. It's my pleasure today, great pleasure today to introduce our keynote speaker, who's one of the preeminent experts on electricity storage, Mr. Brad Roberts. And Mr. Roberts has over 35 years of experience in the design and operation of critical power systems, ranging from single-phase UPS systems to medium-voltage applications. Interestingly, he began his engineering work as a systems reliability engineer for the Apollo Lunar Module program at Cape Kennedy. He has held senior management positions for 2 major universal power supply manufacturers, and he is currently the Power Quality Systems Director for the S&C Electric Company, which specializes in low and medium power protection systems. Brad is a senior member of the IEEE and has published over 40 technical papers and journal articles on critical power system design and energy storage technology. He is a registered professional engineer, and he earned his BSEE degree from the University of Florida. He is also past chairman of the IEEE Power Engineering Society's Emerging Technologies Committee, and he is the current executive director of the Electricity Storage Association, ESA, and past chairman of the board. Mr. Roberts is also a member of the U.S. Department of Energy's Electricity Advisory Committee and chairman of the Energy Storage Subcommittee. Please join me in welcoming our distinguished speaker, Mr. Brad Roberts.
I think can you hear me okay? I think it's working all right. Well, I want to start off and thank everybody for braving the elements today and coming out in what's normally sunny California, but a little off its game today. I want to thank all of you. I particularly want to thank the joint venture and the Silicon Valley Network for inviting me to kick off this meeting and hopefully stimulate a good morning of discussions as we go forward. I need to start, though, by making an apology. I'm not going to talk about energy storage. I'm actually going to help you draw the distinction between energy storage and what I call electricity storage, and that's what we're going to focus on today. If you look at our grid, it does a pretty good job of releasing the energy stored in major fuels. The top 3, the big 3, are coal, natural gas, and uranium, power about 80% to 90% of all the electricity. Now, this is now followed by water, geothermal, and now a big emphasis on renewables, wind and solar primarily. So we've got a lot going on in the grid. And what I want to do is distinguish that by giving you a definition of what I call electricity storage, which is basically the process of taking power off the grid, converting it to another media to store it so that it can be delivered when you want it and when you need it. So that's basically what we're talking about, and what I'm going to spend time showing you kind of where that industry is, what the future is, and what some of the issues that we need to deal with that I know will be talked about here today. There is a dilemma that we're facing, basically. We know that storage media is the key to productivity in natural gas distribution and use, water distribution and use as an example. It's very key to the productivity in this country. Storage is a driver for the consumer electronics industry. If you think about it, this device, if you had to go find a place to plug it in every time you wanted to use it, you wouldn't use it. That whole industry wouldn't exist today, basically, without a small amount of energy storage, electricity storage, as the fundamental of making it happen. But there is resistance to this whole idea of energy storage in the grid, and we need to work on this and look at what can be done to make storage a part of the real grid planning process going forward. If you look at one thing we can't escape is the efficient use of the electric generating capability for this country. The actual peak efficiency or use of grid power occurred in the 60s and has declined ever since and is now down below 50%. Basically what that means is we have a grid that has to be designed to operate the peak 100 hours a year, basically, and the rest of the time only about 50% of the capacity is needed to meet the load. You wouldn't run your business this way. Most of us work on efficiency very, very hard to make sure our businesses become more and more efficient. This whole industry needs to work on this issue and become more and more efficient. What's caused this? What's caused this is the explosion in the use of primarily air conditioning and refrigeration systems. That every home has at least one or two air conditioners in the heat of the summer. Everything is running full tilt, and that's when those peak demands have to be satisfied. And we need to look at building a grid more toward the average load and deal with the peaks in a different way. One of the areas that's going to see a lot of attention and is starting to happen is ice storage, as an example. There's some really good examples out there of ice storage systems for residential and commercial use that take the advantage of the low temperatures at night to create ice and then run your air conditioning system off of that without pulling power from the grid during the day. So there's a lot of ways that we can deal with this issue, and storage in various forms is going to be part of that solution. Now, the big emphasis is on wind and solar, and that does create some volatility in the grid that has to be dealt with, and we're going to talk about how different types of storage systems can be used to balance those energy shifts that are taking place long-term and on a very short-term basis, as an example. So if we look at kind of what the impact of renewables take on the grid, we have to see that basically we have to deal with this mismatch that can occur between loads, sources, or demand and supply. Transmission constraints are a really big issue. And so if you could snap your fingers tomorrow and have 50% of the roofs in the country covered with solar panels, the effect of clouds on the voltage stability in the grid could be an issue. So we have to figure out ways through our smart grid initiatives and as we grow to add more and more storage to the system such that we can have a balanced system under any set of conditions. One of the things, I like to use these next two slides from last year's Electricity Delivery Forum in Washington. And basically the audience was given the ability to vote on a subject or answer a question. And everybody had, like the game shows, had a slide, had a little device in their hands that they could vote. So one of the key questions was, what will be the most transformative technology for the electric industry in the near future? And that was the question, and they were given 10 seconds to answer that question. Here's the response of that group, made up primarily of state and federal regulators who see the energy storage as the key issue that needs to be dealt with, needs to be perfected, and made a part of the whole grid process. This has not gone unnoticed by the Congress. Senator Wyden has introduced the electricity storage bill in the Senate. Representative Thompson from California is in the process of introducing a similar bill in the House of Representatives to provide the ability to have some tax credits associated with implementation of storage by utilities, independent power producers, commercial industrial customers, and residential customers. So that's encouraging. That's a good first step that needs to be some assistance, just like wind didn't happen until the production tax credit came into being, and solar's received some very deserving credits particularly at the local level that have been meaningful in the development of that whole industry. So the value of storage is going to be critical going forward. Pumped hydro has played a major role in the last 40 years, which a lot of people are not aware of. The need for storage is receiving more attention, as I just said, and it is going to be a major facilitator of the smart grid. Smart grid realities are going to need a little bit of storage. And a little bit of storage goes a long way. It's not a case where we're trying to have storage compete megawatt for megawatt with generation sources. That's not the idea. The idea is to use storage to complement those forms of energy generation. I'd like to shift a little bit and talk about storage alternatives and give you a little background on storage. People are surprised sometimes to see what's going on in this arena. The big boy out there obviously is pumped hydro. Those are very large plants, typically approaching at least 1 gigawatt, sometimes larger. Compressed air energy storage is starting to get a fair amount of attention. We'll talk about that for just a little bit. Distributed energy storage in the grid, primarily in the form of batteries and flywheels, is happening. My particular involvement is in this arena. And the new form of storage that's emerging is what's called community energy storage, which is kind of interesting, and we'll spend a little time on that as well. So if we look at storage in the grid in this country and globally, there's a fair amount of storage out there. In fact, the 22 gigawatts in the grid here is about 2.2% roughly of the capacity of the grid, which is not bad. That number, however, if you look globally, Japan is the leader with approaching 15% of their capacity in the form of pumped hydro. Germany is second, approaching 10% of their grid's capacity in the form of pumped hydro. So they've made major commitments in that area. There's only 2 plants in the world, one in the United States and one in Germany. That's going to change fairly dramatically. NAS is sodium sulfur battery systems, which are high temperature batteries that run about 6 to 7 hours. That was developed, actually was discovered by Ford Motor Company in the 60s as a possible use for electric cars, and was abandoned. The Japanese took that technology about 20 years ago, spent hundreds of millions of dollars developing it, and have turned it into a major force going forward in the marketplace. With annual production will easily approach 200 megawatts a year of that going forward. NiCad batteries had some exposure. The biggest battery in North America is a 26 megawatt system in Alaska. And then other forms of storage are just now starting to emerge and will grow very, very fast here and around the world. If we look at each one of those, pumped hydro basically, about 18 gigawatts was installed in the last third of the 20th century. That was a wise decision that was made back in the days when all the utilities were fully vertically integrated and could make the decisions of what needed to be done in the grid. And basically they were put in to support baseload nuclear plants and give those plants something to do in night and weekends, and basically pump a lot of water up to an upper reservoir, and then over the next week during the peak hours drain it back down. Every utility that has a pumped hydro facility sees its value increase every year. So there's a lot going on. There's 20 new projects on the drawing board that totals more than 20 gigawatts that is being planned for the future. The sites that you can do this is a little limited, but there's key areas of the country where this can take place and will happen. There's a 400 megawatt pumped hydro facility getting ready to go into service in Missouri as an example. Compressed air energy storage, or CAES, is something that's starting to get a lot of attention. This is the one plant in the United States, been in for 15 years, down in South Alabama, basically compressing air into a salt dome and releasing that high pressure air through a turbine, blending it with a small amount of natural gas, and you basically boost the capacity of the natural gas system by 3 to 4 times, and end up with a system. This particular one's 26 hours of capacity, as you can see. Kansas and Iowa, as an example, are working on new CAES projects to support wind in their areas. And with the recent DOE stimulus grants, 300 megawatt plant near Bakersfield is in process that received a stimulus grant. And there's a 150 megawatt plant in New York State that's was the recipient of a grant also that should be coming forward. So I think we're going to see quite a few megawatts hundreds of megawatts of compressed air enter the market over the next 2 to 5 years. Distributed energy storage, I really like this picture a lot because it shows water storage and electricity storage side by side. We're all familiar with we take for granted that we have water pressure, and we kind of forget sometimes why we have water pressure, because it's stored to keep pressure in the system. This particular batteries is a unique application of smart grid that American Electric Power did several projects to provide smart grid deployment to improve the service reliability in areas where there's a problem and extensive outages for large areas. These two big batteries have the ability to island or run a large segment of the network independently of the grid when the transmission line to this substation experiences a problem. Most of these cases are long transmission lines, radial feeders that are subject to a lot of downtime, and this way the battery can run a large neighborhood. This typical battery in this picture here, I think, powers about 1,200 homes and provides backup power while or powers those loads. That is combined with intelligent devices in that local distribution area to keep track of where the load is and isolate or shed load on an independent basis. So it's a good example of smart grid technology at work to improve reliability in the system. This is an example of a transportable energy storage system that's part of a smart grid demonstration project in North Carolina that is combining a big solar array that's feeding a neighborhood, and then communication directly to each home in that neighborhood so that the balancing energy that the battery can provide works with the solar. So if clouds pass over or things like that, that energy can be dispatched to balance the energy and keep and optimize the flow of energy in that neighborhood. And so this project is underway. There will actually be a tour of this demonstration project as a part of the Electricity Storage Association annual meeting this coming May. This is an interesting one. The Japanese are very, very serious about how renewable energy is deployed onto the grid. This is the largest battery in the world, 34 megawatts for 7 hours. It's tied to a 51 megawatt wind farm in the northern part of Japan. And basically in Japan, they require that the wind farm's output be fully dispatchable on peak. And they don't want any surprises. They want the power available. In Japan, there's a huge swing between off-peak power costs and on-peak power costs. Japan is baseload nuclear, and all of their peaking is done with natural gas. They don't really have any coal, and so the prices are very, very high, and the power cost can swing from 5 cents kilowatt hour at night to 30 cents kilowatt hour during the day. So being able to shift energy and dispatch on peak with wind, storage, pumped hydro, things like that is very, very important to them, and they take it very seriously. One of the places I think storage will have the ability to participate the quickest is in this area of ancillary services, where only a small amount of energy that can go up or down is needed, and flywheels and lithium-ion batteries are going to make a huge contribution in this area, in what I call fast storage. Today, to accomplish ancillary service or frequency regulation in the grid, the system operator dispatches a signal. Basically, fossil fuel plants, natural gas, and some coal plants then respond to that signal and either try to deliver energy or absorb energy. And this process, from the time the signal is sent till the plant responds, is 3 to 4 minutes. In the case of flywheels and lithium-ion batteries, when that signal is sent, the response is 1 to 2 cycles. So having that ability to respond very, very quickly actually allows you to accomplish the same task with less energy. And so this is a huge, huge opportunity. If you look at the same application with lithium ion, this particular one happens to be down in Southern California. Two of the sponsors of this meeting, A123 and Altair Nano, have done some great work in this area as far as building these kinds of systems and to deploy these kinds of systems in what I call fast energy systems. And I think you'll see this part of the storage market grow the quickest. My hope is that this will happen as the amount of renewables increases in the grid. The need for more balancing energy or ancillary service energy will increase. Right now it's between 1% and 2% of the capacity of the grid. That could get to 3%. So this is easily a market where at least a couple of gigawatts of storage could play a vital role. It's competitive with gas turbine generator costs and has no fuel component, and it's clean. So I hope to see more and more happen in this area. The one that's getting the most attention excuse me, right now is community energy storage. This whole idea of pushing energy out to the edge of the grid has some real merit and some real interesting things going on. Basically, this is going to put storage in your backyard or on your street corner, okay? And this has a lot of advantage. If you think about a neighborhood where more and more solar roofs are being added, more and more people are going to start buying plug-in hybrid vehicles, okay? All of a sudden, the load characteristics for that neighborhood can change pretty dramatically. And if there was energy in that neighborhood that could help deal with that, for instance, a solar roof today, it may peak at 3 or 4 in the afternoon when everybody's at work, so all that energy is being pushed back into the grid and dissipating, unfortunately, quite a bit of losses associated with that. If that could be captured and stored locally, that would be a huge advantage for that particular neighborhood and could help deal with voltage regulation in that neighborhood and the charging patterns for cars and things like that. So there's a lot of work going on in this area. A lot of demonstration projects are going to happen over the next couple of years, and I think you'll be surprised at what you see coming out of all of this. So the other benefit, obviously, is just service reliability. In other words, in your neighborhood. Is that me? No, it's not me. And so I'm really excited about this. This is a huge opportunity to have these units. It's a real challenge to build a pad-mounted, small, high-tech energy storage device sitting in an uncontrolled environment in a neighborhood that it can't make any noise. It has to have incredible communications capability. So this is one of the best examples of smart grid technology going on out there today. So let's talk about where we are. What's needed? Well, better understanding is always a good start. Okay, I can remember 7 or 8 years ago when the San Jose Mercury News published an article about how storage was never going to happen because you just can't store electricity. It's impossible. Similar article in the Wall Street Journal. If you read the recent articles in the Wall Street Journal and things like that, those folks have now, are getting the message, writing some very good stuff, communicating to people. I personally have been doing a lot of community work in talking to business groups and things like that about this whole topic, and it's amazing how people are just hungry to understand what this is all about because they have no clue. And I also warn them that the thing that's coming, the reason they need to know more about this is the price of electricity is going to go only one direction, and it's going to continue to go very high, and you need to figure out how to use it a little more efficiently, a little more wisely. It's not a God-given right. It's something that we need to manage as a resource. And a lot of driving is going on technology. The government is looking at spending about $150 million on research for new technology devices and storage devices, and that's very encouraging. The impact of large amounts of renewable energy, if we don't do something, Curtailment of energy is going to become significant, particularly of wind. One of the key indicators of that is the negative pricing of wind, and more times in Texas now, where a wind developer has to pay somebody to take the energy at night because they want to preserve the production tax credit. So there's the regulators and everybody needs to look at this issue a lot closer because this is going to become a real problem. As that amount of base load, as that amount of renewables, particularly wind, grows at night, that starts to put a lot of pressure on the base load plant operations. When you've got big nuclear plants and coal plants, you can't turn them up and down at will without having a major impact on the economics of their performance. Major expansion of high voltage transmission lines. If you look at some of the studies and all of these big backbone of extra high voltage transmission down the center of the United States, I'm here to tell you, I've been at the meetings. I was at the High Plains Transmission Summit in November, and there's the major players that have to make this happen aren't anywhere close to figuring out how to do it. And the estimates keep going up and up. And so that's going to be a real issue. There's a lot of resistance to big transmission lines through certain parts of the country, and that's a reality of something we're going to have to deal with. Actually, that will not an issue if you look at rooftop solar. The roofs are where the people are and where the load is. And if you start doing more and more solar, I think you end up with a situation you can add renewable energy on peak at it and don't need new transmission lines to do it. So I think this is going to be a major issue going forward. Why is there opposition to storage? Basically, it's been a lack of understanding beyond the bulk energy concept. It's perceived as slow development of distributed storage, that it's something new, there's nothing proven. Up until this last year, there was a total lack of any stimulus funding at the federal level. The government invested $185 million this year. Their storage budget the year before was about $4 million. So, and that was high. So, ironically, in the 70s, the energy storage budget at the DOE was $70 million. So there was a time when we thought that when the price of oil went out of sight that this was going to happen. The price of oil went way back down, and that whole idea went completely away. So the idea that it's too expensive needs to be dealt with completely. So how much is needed? If you take the NREL study that was done in 2007 to show a goal of 20% nationwide by 2030, the NREL study was unfortunately based on megawatt hour production and not peak generation. Okay, so the nameplate data and the numbers you see published for solar deployment, for wind deployment, are nameplate ratings. The actual generation of that wind occurs mainly at night. I'll show you a slide here in a second. And during peak, it's a very, very small number. So it's a mismatch. And to just have the total megawatt hours as your goal and producing a lot of energy when you don't want it is not something we want to do. We need to establish a different goal. And I'd like to see us embrace storage as a way to basically accomplish that. So if you look at a wind pattern, basically, this is what it looks like. Okay, so you've got a lot of wind at night. Right when you need it in the afternoon, when the peak load occurs, you have this problem. Now, as you move north toward Canada, this situation gets better and better. In other words, when you get into Canada, there's quite a bit of wind in the afternoon. Now, the advocates of wind energy would state, okay, if we could have this 3,000-mile long transmission line system, then when it's not blowing one place, it's going to be blowing some other place. So we'd be able to eliminate a good portion of this valley, and that is true. You could in fact do that if you could like spread that whole load over a very large area. So my approach would say, if we did that, the current estimates on the transmission line necessary to do that's about $200 billion to accomplish that. Most of that's in the Midwest. And if you assume the load factor, in other words, by spreading that out, if we could get the load factor up to 40% during the peak periods in the afternoon, we have to deploy 750 gigawatts of wind generators to achieve a goal of 20% wind on peak. Now, if you read the NREL report, it also called for adding fast-acting gas turbines as a way to supplement the grid in case wind started to fall off abnormally, and you could bring these devices on quickly. So in round numbers, if you look at what that all would cost, you're approaching $2 trillion to accomplish that. Okay? Now, if you were to do the same thing, or look at using storage, okay, and face the fact that the transmission growth is not going to be of the magnitude people think. It's going to be some scaled-down version of that, okay, at $100 billion. And the capacity factor because of that is going to be lower. But if we expanded grid storage from 22 gigawatts today to 100 gigawatts over that time period, that would be a $240 billion investment. But the result would be over $100 billion in savings to produce a much more robust grid that has a lot of balancing energy in it. That's still only going to be about 7 or 8% of the total capacity going forward, but that would make a huge difference in how the grid operates and how it functions. So I hope that's something that message is finally getting through, and I hope you will share that belief. Storage in California, you guys always have been leaders in all kinds of technologies. You've done a great job, and in storage you've done a tremendous job. The California Energy Commission has been very creative and done a lot of pioneering work in demonstrating some of the technologies that we just talked about. California was the beneficiary of the lion's share of the stimulus money in the recent round of DOE funding, with $74 million coming to California projects totaling almost $500 million. That's great. The California Energy Storage Alliance has done a tremendous job in increasing the awareness of what's going on. Janice and her group have done tremendous work and really should be commended for what they've accomplished, because I think the message is loud and clear. If you look at what you're trying to do in California, there's some pretty aggressive goals out there that I think is going to be a little hard, but thanks to megawatt storage farms, this is a great map that shows what would have to be done or what should be done to really make this thing work reliably and at its best. And so the key population centers of the state need a fair amount of storage to make things happen. I really think rooftop solar is going to be a major player, because I think that's one of the keys to making it happen in California, and I hope that does happen along with a fair amount of storage to go with it, because I think that's the right solution. And I personally think, as I said, that solar is going to be really the major player here. So, optimizing the use of renewables. No question about it. We need more wind and solar resources added to the grid. It's the right thing to do. We need to do it. We need to provide balancing energy with different forms of storage. We need to really work on implementing the smart grid concept, okay? As I tell people, smart grid doesn't mean talking to your toaster from your BlackBerry, okay? It's making the grid very, very intelligent throughout the grid, not just at the residential level. Just going and putting a smart meter on a person's home is step one, okay? There's a lot that goes on. What that does do, if you put that meter in the house, studies show that customer tends to conserve in the 10 to 15% range just on having information about their use of electricity. If you're going to go on a diet, the first thing you do is get a scale, okay? And if you don't have a scale, today you get a power bill, you complain about it and pay it. You have no idea what you're doing, what the usage is. It's like going to the grocery store and there's no prices, and you just get stuff off the shelf, and they check you out at the end of the month, you get a bill for $780. And you wouldn't put up with that for 1 minute, but you do put up with getting not much information from the utility company. So, and it's not their fault, it's just the way it's been. And so now, once you have a smart meter, that will help you conserve. The other thing I'd like to put forth is the idea of demand dispatch, not demand response. Demand response, goals are set for demand response, typically 5%. So that if the wind starts to fall off or the solar energy is falling off, the renewables are falling off, we turn off everybody's air conditioner. Okay? Just turning off loads is nice, but controlling those loads from when they turn on and when they turn off is really the concept that needs to be looked at. Some good work is being done to look at smart charging of cars. Basically, the message out there is that as plug-in hybrids grow, when they're at home, they need to be plugged in, and when they're at the office, they need to be plugged in, because there's value in those cars, in being able to smart charge those cars. A study in PJM shows that 1 million cars plugged in could provide potentially provide all of the ancillary services for that region, just by how you turn the power on and off when you're charging the car. The demonstration project in PJM with I think it's a dozen cars or a couple dozen cars, basically pays those cars $10 a day to participate in that market. So, you know, there's a lot of creativity that's going to go on. A lot of things are going to happen. Bottom line is, there's a huge business opportunity for this power industry. I mean, things are changing a lot. In the introduction, Tom mentioned my stint at NASA. I hate to date myself, but I did graduate from college in that era when President Kennedy set down the goal of putting a man on the moon by the end of the century. The whole country embraced that. Technology was at its finest. A lot of that technology came out of this region of the country, right here, the control systems and other kinds of things. In that decade, in my experience, I ended up on the launch team for Apollo 11. My name is on the moon. I got to sign a thing that's up on the moon. Only a few people got to do that, and I'm very proud of that. But that helped launch a great, rewarding career for me, and we got to do that again. We got to take this decade and make that happen. I've been the part of two big growth companies in the power electronics industry that are very, very successful today. And now at S&C, I'm having the fun of doing it all over again. We are making tremendous contributions to the smart grid. And our company this year is 99 years old. We started as an innovative company in 1911, inventing the first power fuse in the electric power industry. And we've continued to innovate. And we have worked very hard over the last decade in this whole area of smart grid and energy storage to continue that opportunity. The opportunity to make things in the rebirth of American technology, I think, is something we really need to embrace. Remember, a clean, intelligent electric grid in North America is something that we have to do. We have to be the leader for the world in showing the world how to do electricity clean and intelligently. You've done a great job in this area. I hope that the Silicon Valley companies and the members of your alliance embrace this and be a part of this. As I showed you earlier, this industry alone, I think, is over $200 billion over the next 20 years, and I think it's a great opportunity. And the thing we need to remember is electricity generation and distribution in this country is not something we can import from China. We can't fill up ships with containers and bring electrons over here and plug them in. We have to do that job here. We've made power engineering exciting again. I was a power engineer in the time when electronics was just starting, and everybody said, what do you want to do that for? It's boring, okay? Well, we're seeing a lot of people really interested in being in the power business, and we have to create the opportunity for young men and women to have long, prosperous careers, high-tech jobs in this arena, and we stand to be able to generate many, many hundreds of thousands, if not millions of jobs in this, and I hope you'll all be a part of that. So, the thing that's taking place that's going to really change things also is the electric transportation. Here are two huge industries that are in the transformation process. Energy storage is the problem and the solution for both of them. Okay? Smart charging will be a valuable component, as I mentioned, to the smart grid. 30 million plug-ins and EVs by 2030 is going to be more than 500 gigawatts of load on the grid that needs to be wisely managed and controlled. So both of these industries are going to benefit from battery technology and production acceleration as the pricing gets to be better and better going forward. So it's a real opportunity. If you want to do some additional reading, the reports that our committee did for the Department of Energy is interesting. I would think you might want to take a look at them. There's 3 of them: keeping the lights on, smart grid, and bottling electricity. And then the July-August issue of IEEE Power and Energy magazine was all focused on energy storage. So I think you'll find that some interesting reading if you'd like to know a little bit more. Also, I'm going to end with a commercial. As the Executive Director of the Electricity Storage Association, would like to, if you'd like to know more about this whole marketplace, attend the 20th anniversary meeting in Charlotte, North Carolina, May 4th through the 7th. That will be an excellent meeting. There'll be at least 500 people at that meeting. And it'll be 2 full days of understanding storage technology, the political and the economic issues. And I want to thank you very much for the chance to talk to you today. Thank you. And I've got a couple minutes. Maybe if there's any questions, would somebody like to ask a question? We've got microphones. And uh-oh. Right here.
You're running a test and see the pilot on the community energy storage with AEP, if I'm not wrong.
Yes.
Can you provide a little bit more color on the type of energy storage that will be used and any issues that you're seeing?
The initial units will use lithium-ion batteries, and dealing with the temperature control is one of the real challenges. When you have a device that's basically, like I mentioned, sitting in a neighborhood in an uncontrolled environment. My company has a lot of experience in building the green boxes you see everywhere and learning how to make dangerous electrical boxes tamper-proof. And so, but lithium-ion is the storage media for the first units. Yes, sir.
Yeah, you made a comment, a couple comments about electricity storage being perceived of as too expensive, and you showed an example of the high voltage transmission costs versus using energy storage, and I guess, or electricity storage, to use your term. I guess I'm wondering, do you think that one of the reasons that there's a perception that it's too expensive is that in particular, the wind generators are looking for someone else to pay for this rather than having to pay for it themselves?
That's a real issue. People in the wind generation business would prefer not to pay for the transmission lines and the associated storage that might be needed to go with it. The reality is we have to balance all of these costs. At the Senate hearing before Christmas, Senator Coker from Tennessee made it very clear that that his constituents in Tennessee were not going to contribute to the cost of transmission lines to get power from South Dakota to Philadelphia. That didn't benefit his constituents, and in no way should you expect us to pay for it. So it's a real issue to figure out how and the proper distribution of all the costs associated with growing this whole marketplace. Was there another one?
I hate to cut off questions, but I think we need to move on. But a big thank you goes out to Brad Roberts for coming all this way to share this with us. Thank you very much, Brad. And we're going to move on to our...